In this video, we're really going to go ahead and put our calculus and algebra skills to the test. We have this integral here, 1/2 times the integral from 0 to arc sine of c of this entire thing here. We have some determinants, we have summations, we have some trig functions, and we need to find the value of c that makes this true, and that's going to help us find the c value. That's going to help us find the definite integral. So let's talk about how we're going to solve this. What's going on, everyone? Just so you know, I try to post one of these challenging problems once a week where I encourage people to post their solutions in the comments or just try it out. And I'm going to start posting the solutions now here as a YouTube video every week. So feel free to follow along. We'll try to solve it yourself before you see it. Check it out. Oh boy. Okay, so the real question is, where do we begin? I'm thinking, we definitely just want to find the c value here. So I think we should solve for this and find the c value that's going to make this true. So what we have is a cubic function. And if you try to factor it out, it's not going to really work. So we're going to have to use the rational root theorem. Now, the rational root theorem tells us that the possible roots are some form of p over q, where p is going to be the factors of -10. Q is the factors of the leading coefficient, which in this case is just 1. So it's going to really help us. So the factors for -10 are going to be plus or minus 1, plus or minus 2, it looks like, plus or minus 5, and then plus or minus 10. And then we divide by, I'm just going to write that down, the factors of the leading coefficient, which in this case was 1. So we really just have 8 different options to choose from. And I'm going to show you how we will solve for this. I'm going to use synthetic division to check which ones of these are going to make this true. So let's just say we try 1. So I have the leading, the coefficients of each term here. So 1, -2, -13, and -10. And with synthetic division, you bring this 1 down, then you have 1 times 1 is 1, then you have -1, then you have -1 here, -14, and that's going to be -14, and this right here is -24. We want 0 because this tells me that if I plug in 1 in here, I get a value of -24, so we know that's not going to be an answer. So how about we try, let's just say 5, okay? I'm just going to erase these because I don't want as much space as I possibly can. Bring the 1 down, then this becomes a 5. This is 3. 5 times 3 is 15. Oh, looking good. -13 plus 15 is 2, and then we get 10 and 0. So that means that 5 is a 0. Now we know that the factor form so far is going to be c minus 5 times, these are the coefficients of our value here, or the function, the remaining divisor. C squared plus 13c plus 2 is equal to 0. And now we can go ahead and factor out the rest. C minus 5. We can just get some common factors here, c plus 2, c plus 1. So that means that the values that make this true are c is equal to 5, -2, and -1. Well, they told us that c has to be greater than 0, so now we know that c is going to equal to 5. So far that's going to help us find one part of the integral there. So now as we go ahead and write this, I'm going to have 1/2 times the integral from 0 of arc sine of 5, and then I'm just going to go ahead and try to start solving some things. This right here is the determinant. So how do you take the determinant? Remember, we do 6 times 1, which is 6, minus 3 times 1, which is 3. So 6 minus 3 is going to be 3. So now we know that this value here is going to be 3 times, and I'm seeing a double angle formula with this sine of 2 theta. So I'm just going to rewrite that as 2 sine theta cosine theta plus 20 cosine theta, over, and for no other reason but because I know how to solve this one, I see a sine squared here. Definitely want to rewrite that. I want to apologize. I made a mistake when I wrote this. This should have been negative cosine squared, but luckily we haven't really solved it yet. So if you saw this in the very beginning, I had a negative sine squared. It's actually a negative cosine squared. That's in the original problem that I posted on Instagram. Okay, so this negative cosine squared, I'm going to have a negative, and then I'm going to put sine squared minus 1, and then just continue. Plus 7 sine theta plus, and then this entire summation. So let's just go ahead and start taking care of those things. Well, we have a simple summation that we can go ahead and separate. We have the summation from n is equal to 1 to 5 of 2 values. We have 4n squared minus 14, the summation from n is equal to 1 to 5 of n. Okay, well, we can easily solve this. There's a nice rule for this. Typically, it's an I, and this variable is going to be an I because the summation is 4 times. This is going to be 5 times 5 plus 1, which is 6, times 2n plus 1, which is going to be 11 all over 6. This is really nice because if these cancel out, you have 5 times 11, which is going to be 55, times 4, that's going to be 220, I believe. Minus, and now we continue here, we have minus times 14, and then this is going to be a simple 5 times 6 over 2. These are summation rules that I think you should definitely know. If we divide this, we get a 3 over a 1, 15 times 14, and that's going to be 210. So we have 220 minus 210. This entire thing is just going to be 10. That's really nice because now we can go ahead and write 10 plus our 3, and that's going to be 13. So now we have 13 here with respect to theta. Okay, let's continue. Let's go ahead and distribute this negative sign here. Did I get sidetracked with the cosine? I got so caught up with this cosine, right? Did I do this right? Because cosine should be 1 minus sine squared. I'm sure someone is screaming at the screen saying, this should be 1 minus sine squared, and it totally should have, because when I distribute this negative, I'm going to get negative 1 plus sine squared. So the negative 1 can combine with the 13. That's going to make it 12. So now what we have is sine squared plus 7 sine theta plus 12. I'm so sorry about that, guys. I should have been so much more diligent with that. But as you're writing so many things, it just goes to show how confusing this can be. Okay, as we continue, I think we're getting there. Let's go ahead and do a few things before we try to use a use substitution. How about on the top, it looks like I can factor out a 2. So because there's a 2 here, and if I factor out a 2, this will become a 10. So that means that the 2 can come outside. The 2 times 1/2 goes away. So now we just have integral from 0 to arc sine of 5, which, by the way, I understand that that's very controversial, but we're just going to assume that it exists. This is 3 sine theta cosine theta plus, and let's do 10 cosine theta all over sine squared theta plus 7 sine theta plus 12 d theta. Okay, I feel like we're off to the races now, because what we can do is we're going to use our substitution. We're going to make u equal to sine theta. That means du is equal to cosine theta d theta, which, by the way, is right here. If I factor out a cosine from both of these, then that's going to be my cosine theta times d theta. That's my differential. That's perfect. But let's change our parameters. When x was equal to 0, then u is going to be, I'm sorry, this was theta, not x. When theta is equal to 0, then our u is just going to be 0. And then here's the tricky part. I understand. When theta is equal to arc sine of 5, then sine of arc sine of 5 is just going to be 5. Again, we assume that this was true. I know a lot of people were pretty upset at me, but that's what it's going to be. So now we have a nicer integral. So we're going to go ahead and clean this up a little bit. Okay, so here we go. This integral right here turned into integral from 0 to 5 of 3u plus 10 over u squared plus 7u plus 12. So it looks like we're definitely going to use a partial fraction in composition, but I'm going to go ahead and use what I like to call Scribble's lemma. I believe it's like the residue theorem from complex variables, but when it comes to rational functions like this, I just call it the Scribble's lemma. Sorry about that. So this, I'm going to make my g of x. And my g prime, that would imply that my g prime of x is going to be 2u plus 7. So I'll mention that in a second, or I'll talk about that. This is going to be my f of x, and then my f of x is going to be 3u plus 10. And the reason why we're doing this is because if we're going to use the Scribble's lemma, and if we're using rational root theorem, we know that we're going to have a value of, we have a over, if we factor this out, it's u plus 3 times u plus 4. This would be u plus 3 plus b over u plus 4. Let's put parentheses on both of these, du. Okay, well, we got to find the a and the b value. We can easily do the cover up method. Some people probably already know what this is, but one of the cool things is that a is going to equal to f of negative 3 over g prime of negative 3, where negative 3 was the value that made this undefined. So this is going to become 3 times negative 3 plus 10 over 2 times negative 3 plus 7. And the way I got this is because this is my g prime and that's my f. So if we simplify this as negative 9 plus 10, that's just going to be 1 over negative 6 plus 7. That's just 1. So there's our a value, and our b value is going to be f of negative 4, because that's the value that makes it undefined, over g prime of negative 4. And this is going to equal to 3 times negative 4 plus 10 over 2 times negative 4 plus 7. So let's go ahead and simplify this. Negative 3 times negative 4, negative 12 plus 10, that's negative 2 over negative 8 plus 7, which is negative 1. So that means that the value is going to be 2. So this right here is simply the integral from 0 to 5 of 1 over u plus 3 plus 2 over u plus 4. And you can definitely verify that that's going to be the answer. Now we just go ahead and continue. This is going to be natural log of u plus 3 plus natural log of, or 2 natural log of u plus 4 from 0 to 5. Now we go ahead and plug in our 5. This is going to become natural log of 8, because 5 plus 3 is 8, plus, when we plug in a 9, or we're going to plug in a 5, 5 plus 4 is going to be 9, and then we can square it. So that's going to be natural log of 81, and that should be, no, that should be a plus, minus, and now we're going to go ahead and plug in the 0. 0 plus 3 is just 3, so natural log of 3 plus, and then we plug in the 0, 0 plus 4, or 0 plus 4 is just 4, and then you're going to square, you're going to have natural log of 16 on here. Okay, so now we can go ahead and combine these. These are being added together, so by properties of logarithms, you're going to have natural log of 8 times 81 over, and now the reason why I said over, because this is being subtracted, so it's going to go on the bottom here in the denominator. Now we have 3 times 16, 3 times 16, and we can simplify this. This becomes a 1, this will become a 2, and then this becomes a 1, and this becomes a 27, and we get a simple answer, natural log of 27 over 2. You don't need the absolute value, but I just wanted to leave it there. And that, my friends, is how you solve the challenge problem that I posted just the other week. Oh my goodness, that was so much fun. And honestly, I'm a little out of breath just because I was talking so much there and because I had a really big lunch. But anyway, I hope you guys enjoyed. Please subscribe to my channel. Follow me on Instagram, on TikTok, where I post these challenge problems, and I'll post a solution on here every single week. I'll see you in the next one.